Greetings, you've landed at the VUC, IP Communications and VoIP Community. We would like to thank Simwood.com for their support. Simwood can turn you as a developer into a telco. Our hosted PBX is from onsip.com, and you can go to getonsip.com for a URL people can click to call you. We've been privileged over the last 5 years to be using the best conference bridge on the planet. Yes, I'm talking about zipdx.com, full color, full featured, full HD conference bridge. Our website, vuc.me on the webs, hosted by bluehost.com. And our worldwide local rate dial-ins are from voxbone.com. Very cool. And we're not only privileged to be working with ZipDX, but we're also privileged to be working with Chris Matthieu today. And I'm going to welcome him in just a second, but a couple of very, very quick things. Oh, James is looking dapper. Very quick things. First of all, Tad Hack Mini London, and Mr. Bodie will be there too as well, by the way. That is the 9th and 10th of April in London. You can win 5K, or that's the pod, I guess. But anyway, you can do your pitch at wherever that is. Did we lose Chris just now? Anyway, let me move on. Kamayo World will all be there, and he's back, Chris. We'll all be there, Berlin, May 18th to 20th, and while we're waiting for Chris's network to settle, I'm going to just put up this thing just briefly, just to show you that we are also encouraging you to go to EFF.org and maybe throw 5 or 10 or 25 or $25,000 their way to do the good work that they do. And now, without further ado, I know you're dying to see me, so here I am. And let's welcome Chris Matthieu. Chris, always great to have you.
Hey, Randy. Thank you so much. It's always a pleasure to be on the VUC.
And you are the #1 mustache on VUC as well, so thank you for that. You win every year. There's just no way to get around that. Chris, what are you going to be taught? We're not going to ask you how you got into tech or any of that, because you've been here 100 times. But what is computes.io?
Yeah, it's a new side project, and I am literally trying to build the world's largest supercomputer.
And how, pray tell, let me guess, we can all participate in this.
Yeah, absolutely. So I started, as you know, I've been tracking IoT for a while, building a lot of IoT platforms, yeah, with OctaBlue and what started off as Skynet, and that's on a VUC episode or two. But I've been doing a lot of thinking that these devices, there's supposed to be 50 billion connected devices to the internet like in the next 4 years. So an explosive growth of hardware. And I started thinking like even my Mac, it's even when I'm working on it, it's idle probably to some degree quite a bit of time. So I started thinking, what if you could leverage all of these new IoT devices and even existing computers, Macs and browsers and phones, to collaborate, if you will, on contributing their cores to a globally distributed supercomputer effort. And I was so fascinated by that idea, and I've kind of been hacking, evenings, weekends, and it's getting a little bit away from me. I'm in pretty deep, and it's actually working. So it's kind of cool. I wanted to show it off with you guys today.
Chris, what was it was SETI who was famously doing that maybe first 1,000 years ago when we were practically on dial-up almost. And then there was another project after SETI or in parallel with it, right? Or is SETI even still happening, by the way? Because they'd have to share their cycles with you if people are doing that. We haven't found anybody yet.
Still happening. It was like a screensaver. So yeah, as you walk away from your computer, the screensaver would come on, and the project was sending you, I guess, audio files of what they've collected in space, and then your computer was supposed to look for signals in that audio file, and then report back true or false. This sampling found a signal or not. So. There's another project that I'm aware of called Protein Folding out of Stanford, and it's doing like cancer research, looking for like Parkinson's disease, they're very specific types of cancer and disease-related things, issues that have to do with how proteins fold. So very similar. They send a data set down, and everyone participating gets to analyze it and return a true or false.
And what we're talking about with computes.io is something quite different because it's not that you're working for a particular cause. So let's hear about it. You take it over.
Yeah, so I mean, we could have causes involved. You know, I started experimenting with this, and a couple of universities did reach out to me saying they had 20 to 30,000 computers that were available to maybe do some type of computing on. So that was an interesting side effect. Is while this is definitely designed to be a globally distributed supercomputer, a company or an enterprise could essentially take all of their desktops, and you know, in the evenings or even during the day, if they're not being taxed, they essentially already have a supercomputer if they know how to harness the computing of all the machines in their network. So law enforcement had a couple of calls from some law enforcement organizations asking about like password cracking. Like, for instance, you know, in the whole rise of the Apple scenario, I think people are starting to wonder. You know, say there's a drug crime, for instance. You know, they seize a bunch of equipment. Local law enforcement agencies do not have computing power like NSA does to crack those, you know, those Windows machines or what have you. So they started thinking, well, what if I can put my 250 offices machines onto computes, and then maybe start adding other law enforcement agencies to pool computes together. Perhaps we could crack some passwords and get into these seized equipment.
That's fascinating. Yeah, there certainly are many great applications. So that's good. However, your effort is going to be quite different because it's not hardwired to one thing. That's what's interesting about among other things. That is something that
Yeah.
completely makes it different.
Yeah. So I'll do some demos. I'll show some screens. You know, some walking through some scenarios. But lately, I think it was 3 weekends ago, I made it so that you can sign up for an account and you get what I'm calling a domain key. And what that means is you can start spinning up your own clients, your own computing clients, and send only your work, you know, to your own machines. So you know, that really allows any developer, you know, that wants to start doing machine learning, you know, algorithms or anything where they need a lot of horsepower, and they can find, you know, the machines to run them on. You're essentially creating your own globally distributed kind of AWS Lambda like service that you're in total control of, and you know, outside of your CPUs, it's not costing you anything. You're just with computes, you're able to collectively distribute work across, you know, thousands of cores at the same time.
Yeah, we have to know more about this. So computes.io, computes.io is where you go, and hopefully there's a clear link to get started. And I see
Yeah,
he's
there
sharing his
is.
screen. Go
Yeah.
ahead.
So I'm sharing my screen. If you go to computes.io, you'll see up here like there's 20 cores connected to the platform today. 16 of those are 4 Raspberry Pis that I have as a Beowulf, which I'll show you in a second. That kind of started the whole thought process. But you come in, you sign up, and what it gives you is a domain key, which you can reset, you know, if you need to. It gives you a Docker image, a Node.js client that you can run on, you know, Windows, Mac, or Linux, and it gives you a browser URL that looks something like Hack the Planet from hackers. But you can see down at the bottom, it's telling you what its UUID is. It's looking for computing jobs, and it's telling you, you know, how many cores are connected to the platform. I also created a Chrome extension where you can come in here anytime you have your Chrome running. You know, you can say, let's turn on my extension to also be doing computes in the background. So this is probably the most important part. Understanding computes. It is a let me show you a slide. It is based on JavaScript. So I've tried to say, how would you build a supercomputer today if you came at this from a different perspective? Since the beginning, it was like, how many more cores can we add to this fiber optic connected backplane that just for speed and locality, crunching a bigger and bigger and faster computing operations. My approach was like, step back. We've already got 20 billion connected devices. How can we distribute those maybe through a mesh network, kind of like along the lines of some of the earlier thoughts around IoT? But more importantly, JavaScript is turning out to be the language of the web, right? So I mean, browsers have been able to run JavaScript for 15 years or longer in the client side. Node.js basically is JavaScript on the server side. That's been around for 4 or 5 years. And then lately, there are hardware microcontrollers coming out like this Tesla here that run JavaScript natively on the microcontrollers. So I started that played a lot of thought process into this. That if all of these microcontrollers and servers and clients run JavaScript, that should be the language of computes as well. So essentially what you're doing is you're running a client that knows how to communicate with computes.io, and you're basically, you build a kernel, which is your compute operation, and how it's going to send out a bunch of computing jobs globally to any worker online that you're allowed to compute with. And then you're sending them JavaScript functions and data. So universally, that's why this platform works on, I was showing you in the web browser and the Chrome extension, but also the Node client, which I'll show you in a minute, running on all platforms. And I don't have an iOS and Android native client yet, but those will run in the browsers. And then, interestingly enough, there's kind of a catch-22 here. If we stumble on some work, for hire, and we don't have enough cores day one, I did write an AWS Lambda function that lets you distribute computes work to Lambda. So you basically have an infinite computes in this idea. And that kind of symbolizes the logo there. It's kind of like parallel processing to the nth power. Infinite computes, any device, any machine, globally distributed simultaneously.
Fantastic. Does anyone have any questions on ZipDX or any of the illustrious panel?
Yeah,
James.
I've got a question. What's the going rate now for Bitcoin mining? Because I just wonder whether it could be a profitable thing to harness a whole load of spare clock cycles to do Bitcoin mining. He says.
I don't know what. Yeah, I don't know what the rate is, but I think that's an excellent idea. So I promised I would go back to the Beowulf. This is what started a lot of this proof of concept. Will this work? What I'm showing you here are the 4 Raspberry Pi 2s that I just taped like double-sided super tape to this 8-port Ethernet, gigabit Ethernet switch. And as you guys recall, the Pi 2 is a quad core. So essentially, when all 4 of these Raspberry Pis come online, you have 16 cores at your disposal. And I think the total price tag on this device was this contraption was around $150. If you go to beowulf.computer, you'll see the whole instruction on how to actually build this yourself and download the image yourself to run these on computes. But once I connected all of this stuff, I was like, well, now what do you do with it, right? You hear people building these Beowulf computers all the time, but how do you actually harness that power? So I wrote the computes.io client basically runs on each one of these boards automatically. You'll see here in a second. I'll do a demo. The computes client, it interrogates the board and says how many cores are on this board, and then it spins up like a cluster. It spins up like it forks the process by that many cores. So literally, there's 4 instances of computes running on each Raspberry Pi 2, and then they're constantly asking for computes to process work. And then they're returning work, and you'll see how the API works. They're just responding in results and asking for more work. So you literally could throw like Bitcoin mining. If you had a JavaScript implementation at one of these at a cluster like this.
So just before I forget, the last I heard, the Bitcoin mining is now your chances of actually getting a coin is so small unless you've got a dedicated hardware, because the amount of computing and the time span you've got in it is actually not amenable to being done on non-dedicated hardware, allegedly. So it's all ASICs these days rather than general purpose computers. But that may just be an algorithm thing. If you get the right algorithm, that story changes, I guess.
And I wish Maxim would be able to unmute and make a comment, because he was in on that in the very early days. He may not be doing it anymore, but he would know. I queried him on IRC, but no answer. Maxim, if you're listening, and you should be, somebody's listening with your name.
I thought the Bitcoin stuff was dominated by either dedicated hardware, FPGA-based stuff, or GPU-based implementations at this point.
So, but this is kind of an interesting implementation. When you set up, I'm kind of getting into some code here, so I apologize for those that aren't as techy. But when you look at like how you set up computes operations, since you own those cores, AWS Lambda, obviously 5 minutes I think is the longest they let you compute today on a Lambda call. But since you own these cores, you can set time to live. So you could make the job run for days if you wanted to per job. I've heard the same, that it's getting more and more difficult to actually find coins.
Hey Maxime, you were muted, but now you're not.
Okay, can you hear me now?
Yes, indeed.
Yes.
Okay, no, what I wanted to say, I mean, it's definitely correct what's been said, that you really need to have an ASIC in order to mine Bitcoin. If you, even if you accumulate enough processing power on the compute platform, then probably those people that participate would want to have a cut of that, and therefore it's not going to be worth it for Bitcoin mining, right? Unless you are the only person that gets the return and you have a huge user base that basically contributes for nothing, right? If that makes sense.
Yeah, there was a node knockout winner called Tidbit several years ago that had this scheme where instead of running advertising on your website, you could run their little JavaScript Bitcoin miner. And yeah, I think they ultimately got sued for like $1 million and shut down just because people that were their browsers, it was not explicit. There was no money coming back to them. So yeah, that's a dangerous water, I think. I agree.
And yet, corporate America has, tens of thousands and perhaps millions of desktops sitting idling most of the time. Yep. And how do we tap that, right? So.
Yep. I was talking to a very large construction company. Some of you guys might know who I'm referring to. And they were talking about 3D modeling and things that you would think like Pixar or something would need computing power to do, and they had 20,000 computers that they were saying that they were looking to deploy this as a test pilot just to see what type of how could they leverage all of those idle machines more effectively. I think there's a lot of promise in this. If you do have to Well, you do have to understand like how to write, JavaScript so that's entirely asynchronous and you're just distributing, massive amounts of computes out. Um, there is another thing I did, with the law enforcement idea in mind. There's an open source product called software called John the Ripper. And John the Ripper is excellent at like finding, breaking hashes or finding all sorts of breaking encryption or passwords, etc. So, but it's a C++, I think, native app. So I did create this version. Well, not just a version. I added an API to computes called execute. Let me find this code here. Yeah, so I added this operation called execute that will then run. It's able to run binaries on those machines. So if they're your cores and you have a binary installed like John the Ripper on, say, thousands of computers, you could execute, a command line operation with lots of parameters, what keys to look for, etc. And then they can return results to you from the binary. So this was an interesting idea that rather than only JavaScript, if you had like a 3D modeling application or something like that that was written, to run, faster or heavier lifting, that's a candidate for this as well now.
Well, that's the reality of the Disney Pixar folks, is that they're running some relatively heavyweight rendering engines in order to produce frames, but they tend to be doling out frames to something that's running their entire rendering suite, be it RenderMan or something else.
Have you looked at asm.js, Chris? Basically compiling your C to a JavaScript subset.
I don't think that I don't think that I have, Tim.
It sounds like you should then, because that's one way that you can do it. If you've got a piece of monolithic C that doesn't actually use kind of ioctals or anything kind of low level, but is heavy C, you could asm.js will generate like a big chunk of JavaScript that runs it, and you can basically compile C to JavaScript now. It sounds insane,
wow.
But it actually works better than you think.
Well, I tell you that could be a clever solution for making more workers, native. I guess taking native workers and making them able to run on anything. I think that's brilliant. Let me walk you through kind of like how this works. And if you go to computes.io. You'll see the cores there that already have your domain key built in. But if you go to kernels, this explains how to actually start experimenting with it. So you npm install computes, and then you'll notice here this is a very vanilla, like small little script that's going to compute 9,000 factorial for you across using 3 cores. If you look at it, you define the operation. You just pass in the JavaScript string as the operation, or you can just give the operation a URL, like maybe a gist, a raw gist, or a paste bin, or something like that. You can give it a URL. You define the parameters. Again, this is the time to live, the priority you want it to run across your cores. Should it delay? This connect actually connects your core to computes.io. When it's connected and communicating, you get an onReady event that fires back. Now here's where you actually set up and distribute your work. So I say loop 3 times and call that, pass the JavaScript into computes along with the iteration, the data of the iteration. And you'll look in my formula. I'm using that data coming in as a multiplier on the iteration, and then as the results come back, or as the results come back from the core back to the kernel, you get an onResult event that fires, and then you can multiply all of the results together. let me show you like what it would look like. So if we come to here, I'm going to run my computes there. And let me scroll back up. Notice it detected 8 cores, and it's running on 8 cores. So I'm running on a MacBook Pro with a i7, I think it is. And it's giving the domain key in here. This is an array, which is kind of interesting because if you say, I'm allowing my computer to run computes.io jobs from multiple kernels, you could just list out all the domain keys you want there. So, I mean, one could be, fighting cancer, one could be fighting crime, terrorism, and then another one could be my own personal computing efforts. So what's going through here, what you're seeing here, is it's doing a CPU check every second and saying, okay, you can set the threshold. You can say don't do any work unless I'm under 50% utilization. What it also scroll here. There's also this little red thing. I wrote a really basic routine that tries to spin as fast as it can to see how many machine instructions per second this machine is worth. Only because I'm thinking that the kernels or CPUs are not all the same, obviously. A Mac is going to be much more performant than, say, a Raspberry Pi 3 or 0. And I think if you need work targeting certain types of kernels, you could set up domain keys for each type. Or eventually, if this ends up being like Uber for computing, maybe people get paid according to the size of their core they're allowing work to be run on. Oh, back to my demo. If we let me show you. It's npm operation. This is basically that demo I have on the website I showed you in the kernels, except in the result, I'm actually multiplying each of the results back together to get the 3 cores to tell me what 9,000 factorial is. So if we run this, npm operation, see it's connected. Now it's already getting results. So it got the 3 results, it disconnected itself, and if I scroll up this massive number, ooh, that's a weird number. There's a lot of nans in that. Hang on, let me rerun this. You can actually see the work coming in here. So here's the client. You can actually see it finished. There's the results. Let me go back to here. Sure enough, the answer to 9,000 factorial starts with 809 and it goes all the way down to there. I just show you like the AWS implementation. It looks very similar. Except I'm sending it to AWS Lambda. I'm still doing all the same work there. So if we do a node npm AWS Lambda connects to computes, now it's sending the computes to Lambda. Which Lambda, unless you're throwing a lot of work at it, it's not hot cached yet. So it takes a little while to spin up that Lambda instance. But we should start seeing results start coming back. There they are. And in theory, we should get the same answer, right? If we scroll up, yeah, 9,000 starts with 809, something, long, big, long number. So that's kind of interesting that you can just take a function, distribute it anywhere in the world, and the cores that are available under your domain compute the result and return the results in your kernel is currently what's responsible for simulating that operation back into an answer. I think future versions of this might allow the kernel to run in the compute's cloud, where maybe you wouldn't have to keep your laptop open as a kernel processing the job.
Chris, is this something that's open to people who don't necessarily know a lot about all of these technologies involved?
It is, and in fact, I'm glad you asked because I've been thinking a lot about that. So as I've been writing these little test ideas, playing with factorials, I started playing with sentiment analysis. I started thinking, what if there was like a directory of functions, if you will, that anyone could use. So you could just like out of the box go and leverage computes that other people have started. And I created something. Let me see, computes. I was calling them operations. I think I might call them functions. Where you can see in here, I have a sentiment analysis and an MD5 password cracker, hashing cracker that are open. So if you look at like sentiment, you'll see here. You pass a string into it, and you get back a score, whether or not it's a good sentiment or not. And there's kind of the sample script how to do it. And I think I'm going to make this even easier. So I'm going to pass in like I love Skynet. That's the string, and then the result comes back here. So let me actually run that for you to show you. So like we do node npm sentiment. Connected, it ran it, and it got back the results. So it got back, so it tokenized my string to say there's 3 words in it, and the word that tripped the sentiment was the word love, and my score came back as a 3. Well, I mean, Watson, I was looking at Watson, kind of gave me this idea, IBM Watson. They have this thing that they're calling Watson apps. They want you to pay for it, and then they want you to pay for Bluemix and all of the computing and stuff, but they have a tone analyzer where that's all you do with it. You send it an email or a web post, a blog post, or something that returns a tone score. I was thinking, if we could build this this directory of supercomputing operations out, open source that, and then now everyone can contribute. And what I was thinking is you could even pipe them back and forth. So I started playing with this idea. I call it's basic MapReduce, but I was on Pi Day, I was playing with the formula pi where you're trying to calculate pi, and you need to do it sequentially instead of like parallel with this formula. I can't remember the name of this formula, but you would basically say send this compute based on the results. Send another compute and either add or subtract. So you're alternating, adding, and subtracting. So on result, I'm just kind of walking through this, and I'm getting the result, and then I'm initiating another compute from the result. So this is like classic MapReduce. And I was thinking this is really interesting when you start thinking, depending on the results that come back from a computes operation, say like sentiment analysis, I may want to do something else, based on the score, and allow you to start writing applications, if you will, that run, globally, and are really alive and sequential and processing, if you will, rather than just steady at home results, true or false. Make these things actually function like machine learning algorithms, based on the results. Maybe the formula changes, or the data of the next input changes, and this thing starts becoming, I hate to say the word aware, but it starts becoming more capable of dynamic computing.
Okay, back to my question. I mean, you answered it, obviously, but back to my question in that, let's roll back. I want everybody who's within the sound of my voice to roll back your knowledge of Node.js and all the rest of it to say you go to the site, computes.io, and at some point, everything's based on, and we've seen what you're typing, Chris, npm, excuse me. Yep. npm. Well, I had never heard of that, but I'm kind of intrepid, so I went and looked for the install, and there is a page on Node.js to install npm on various platforms. I haven't done this yet because I don't know exactly what it does. So can you backtrack just far enough to say we install npm and then we can run these commands, or is there a bunch of other stuff that has to be done?
So there's a couple of things to make your life easier. If you're running just from the client perspective, you could just run this Docker image, and that basically has Node.js and everything pre-compiled and packaged in the Docker container. And you can run, say if you have the resources, you could run, say, 1,000 of these instances of that Docker container. And each Docker container, would act as a core and add to the compute's count. For the kernel, you do need to have Node.js running on your machine today, and you can just as easily, like if you're Windows or Mac, you can just download and install Node. You go to nodejs.org, and you can install it just like you would a normal native application. You don't have to get into the command line for that.
Right.
If you're Linux, I think you do have to compile for Linux. I can't remember if they have a distro.
Yeah, but if you're running
for
Linux, you know how to do that, obviously.
Yeah. So I mean, literally, that's all you need to do is you need to, for the kernel side, you need to have Node.js installed, and then you can literally copy and paste this code on the kernels tab of computes.io and run it, and you're computing factorials, without any computing programming knowledge.
Right. So this is the way to try it. What I'm getting at is, even someone like me, you can find this stuff and download it. You can check the veracity of everything, the keys and so on, make sure you're not downloading malware. But once you've figured all that out, you can run this, and that's really what I wanted to get to. And then after that, because I think I'm very typical of a lot of people who will copy and paste code, and then eventually you go, well, wait a minute, what if I change this to, and then that's probably the most common way to learn if you're not a computer scientist.
Yep, and what I'm hoping to do is maybe not this weekend, but next, hopefully I'll have a little bit more time. I was thinking about really making these operations like that sentiment analysis or the MD5 cracker, scenarios really, really simple to use. That way, maybe it's even less of a barrier to entry to just start experimenting with any of the operations or functions that are already built to play with. Right.
Got to lower the bar. Got to make sure that everybody can get into this. Any more questions from anybody? By the way, Chris has to go fairly soon, so let's see if there's questions from James, Andy, Michael, or anyone on ZipDX. I'll shut up and pause, and we'll see.
I'm just trying to catch up, having missed the start of that. In fact, the first 20 minutes or so.
Shame on you. Shame on you.
I do so apologise, and especially to Chris as well.
Oh, no worries.
I'm off at the dashboard, so I've just signed up, and it's given me my domain key. So that's presumably that domain key applies to me rather than the domain. Is that right?
Correct. That is your key that only your cores will do work with.
Okay. So if I want to build a network of this, I have to pass that domain key to others to use. Is that right?
Yes. So do you see like on your dashboard it has the Docker command or like the Node.js client command that has your domain key already pre-populated?
Yep.
So when you run it, your cores will automatically start up with listening to your domain key.
Excellent. Right. I have a feeling I found something to do over Easter.
One thing we talked about right at the beginning, just want to make sure you caught it. Let me stop my clients. Let me restart them. There we go. You can basically pass an array of domain keys in as well. So if you wanted to do different types of work, if you wanted to allow your core to do different types of computes, you could set up different domain keys to be doing different things, and then that way your core is always listening for any work on any of those domain keys that you pass it.
Excellent. Okay, that all sounds very good. So if I want to get more than one domain key, do I just sign up multiple times?
Yeah, unfortunately, that's the way to do it today, but that's easy enough. Yep.
Okay, that's
okay.
really
I've
good.
got another quick question. How easy is it to change your domain key, as you've just shown us yours, Chris?
Yep. So I have in the settings here, you hit that one button.
That's useful, isn't it?
Yeah, it gives you a new one. I mean, the only trick is, you have to, your commands change. So you would just launch it. Well, I do it. Let me show you how it is. So if I hit reset, it says domain key reset, and look, there's a whole different domain key. So when I launch my core this time, now I'm running under my new domain key. Obviously, if you have, thousands of Raspberry Pis, like running your own Beowulf cluster with the domain key burnt into the SD drive, it's going to be could be a little bit more effort to change, but pretty easy, right, like this.
So, Chris, let me see if I missed the first few minutes, so I may have missed something here. But so that's the security model, that if you have the domain key, then you can run things on that core.
Yep.
And then, but is there any restriction on what that can do? Are there like blocked operations? You can't write to disk, or you can't probe a local network, or anything like that?
Yep. Good, excellent question. In fact, since all of this is JavaScript, it runs in sandboxes. So the Node client has the JavaScript sandbox implemented. So you can't write to disk, and you only have access to what's in that JavaScript function's memory. I was playing with this idea that since all of this is connected to Redis, I was playing with the idea that maybe across your domain keys you could also leverage Redis as memory, which is an interesting idea, because I think you could say this is like global memory for my entire domain. And as these cores are finding results or stuff, they can start updating memory that all the other computes have access to as well. I haven't implemented that, but I'm playing with that idea. But it is a sandbox, a very JavaScript sandbox.
I like that. So my next question was, have you thought about using, instead of being able to trigger stuff from the command line, have you thought about being able to trigger it from within a browser? So if there's a bunch of cores out there set up running, can I, from within my browser, kind of kick off something in those cores?
Yes, so that is top of mind. That'll probably be next weekend too.
Okay.
What I'm planning on doing is exposing a new API, that's a messaging API basically, and then that way you can say message my domain key this function, and then basically that webhook basically just spins off that first computing job. And then what'll happen is you would need to keep a kernel running somewhere. I think that's where it's going to fire. I think the webhook's going to tell computes.io to tell your kernel, to send a message to your kernel that says run this job, and then what'll happen, that'll kind of fire. There'll be an on message that you could then send like a compute operation like that, and then in your results, then you could go crazy. You could say, now that one webhook could then spawn off, say, thousands of compute requests or something. I was thinking like that, like about the sentiment analysis. Like something happens, and then the webhook just like invokes the sentiment analysis based on the score. Then it could start, doing different functions.
Actually, just thinking of it as an easier way to get people like me and Randy started. So you could have like a pool of cores that are available, maybe donated to the project, and then people could just like type in a bit of JavaScript into a web page and kick it off, and it would come back with the answers.
That's exactly how Watson does it.
Right.
I was playing with, and I think you're right. I think that's like, from a salesperson's perspective, that anyone can dabble with that, and you can see how it works. I think that's an excellent idea.
I mean, there are some decent JavaScript editors on the web, so you could do it on that basis. You could almost get it as a JS fiddle.
Yep. Exactly. It's like their tone analyzer. That's exactly what you do. You can come. Where is it? They have a list of like all their apps somewhere. It'd be very similar to what you're talking about. You can just go and like let's see, say browse APIs.
So on that page you were on before, top right-hand corner had
here.
App Gallery. There we go.
Here we are. So here's their concept of what they kind of gave me the idea of a directory of functions. But you can come down. Here's a tone analyzer. The documents maybe. No. Maybe it's this. Learn more. Yeah, here it is. So you check it out. There. So you can just play with it. Basically, give it some text, hit analyze, and then it would, in theory, run the computes and then give you back some results. I think that's a great way to market how it works without exposing people to code right away.
As if exposing people to code was some horror, unspeakable horror.
Look away.
But you're seeing more and more people coding in the browser. I mean, the microbit has a set of effectively an in-browser IDE, and you can code the microbit directly in your browser these days, as far as I understand it.
Yeah, and Tim, that's a good point, because then you could take see how this computes is actually running jobs. Basically, your web browser that you're playing with is basically your computes engine that we wouldn't necessarily need to have a donated sample of cores. Your browser's the core.
Right. So you could kind of get a feel for the language locally, and then once you'd said, yeah, okay, I've got this. In fact, I've got this thing working, and now I want to run it on a real 9,000 factorial rather than 9 factorial, then we go and kick it off on lambdas. And can you earn money by reselling lambdas?
I bet you could. I mean, lambda's price is so cheap. I bet you could. Because you're really paying for the value add, right? You're paying for the thing you're computing, which I think is more valuable than the compute.
Sure. Well, assuming you've asked the right question.
But I love your idea too about actually letting people experiment like in a fiddle, and then you could say now deploy this to my bank of cores or something, my globally distributed network of cores. Very cool.
And all of a sudden it went very, very quiet. What is that?
Yeah, well, it's because I was trying to determine the question that had the answer 42, and I forgot what that was.
Now, I'm a non-developer. I'm a customer. So let me pose this question. I'm given to understand, and it might be dated information, that breaking tasks down so that they can be distributed like this is not always easy or a skill that's commonplace. Is that true? I mean,
yep.
It
is very true. And that's another paradigm. I'm glad you asked that question, because the old days of programming in C and JavaScript, or Java rather, and they're very sequential. And then everyone made the switch to asynchronous programming, very much like Node.js, where you have to learn that everything's a callback. You're doing potentially thousands or hundreds of things at one time simultaneously. And I think with computes, you have to even go back even at a lower level, saying these are all compute operations, and you can set the time to live that this might take a minute, this may take 5 minutes or an hour, and then based on these results, you have to write it in such a way that you can distribute it, thousands of times, and maybe change the data elements, and I think that's what SETI's doing. I think the compute operations all the same across every core, and they're just giving different sample data, to look for audio signals. And I think that's the folding proteins. That's how that one works too. They're saying, here's how you understand if a protein folds. Here's some new DNA data or something.
But I think your thing with Redis of being able to kind of assemble the results in a database is nice, because then it doesn't really matter what order they complete in. So one of the problems with this is that you may have like a sequential something that isn't, you can't actually do the end result until you've done all the bits and you've got them all in the right order. So the nice thing about doing it in Redis is you could just like, as they happen to get done, you post them into Redis, and then once you've got everything, you can then run through, have a last job that runs through all of them, adding them up, or finding the mean, or whatever it is that you need to do with those segments. So I think that's an interesting. I like I think Redis is a kind of critical part of this. Otherwise, I think it's going to be much harder to keep a track on, or you're going to narrow the problems to things that are really asynchronous. Whereas if you could put Redis in there, you can kind of have it sort of loosely serialized, if you see what I mean.
Totally agree with you. I think that's a critical component. Let me show you one more demo. We're kind of got 9 more minutes before I got to jump on another call. This is the MD5 password tracker that I have like in the open operations that you can play with. In this example, it's just passing in the URL of the JavaScript. So if you go look at the JavaScript, this was on GitHub, open source. They claim to be the fastest iteration of JavaScript implementation for MD5 password cracking, but it's got some limitations where it only works. It must work with 8 cores. The mathematical way the algorithm works, you have to throw 8 cores at it. But what's cool is we're going to take this operation, reference it by a URL. When this kernel connects to computes, we're going to set the data. We're going to say, hey, the max password length that's hashed is, say, 5 characters, and here's the hash that we need to crack. And by the way, there's 8 workers, yada yada. What's cool, and I think my global SIGINT has a bug in it, but what the idea is that you could throw all of this work at 8 cores once it's and divide it up, so they're all grabbing different sections of the hash to work with, so they're all working simultaneously at different ends. And then when one finds it, it's supposed to tell all the others, I got it, stop working. And let me show you how that works. So if we say node npm md5, set that hash in, it's connected, and it's already got it. So one of the cores, so yeah, the SIGINT's not working, but it should have told all the rest of the cores to stop working. So what we've got is, look, there's all the cores worth of computing trying to crack that MD5. It was the password heya that is what this hash is equivalent to. So you can see, with this idea of SIGINT, if it was really working right, you could throw a bunch of work at something. When one core gets the result, it could then move on to the next problem, potentially. All the cores could move on to the next problem.
Makes me laugh because that's essentially my password everywhere. Chris, another very quick question though. No, I actually dared install this npm while we were talking, which I normally wouldn't do, but I figured I'd do it. But just to get people started here, so I've got that installed. I'm running a Mac, but you could do this on Windows too. But I can't quite see how you run any of these things now. I've got the domain. I have that installed, and I have the domain key. What do I do to do something?
So once you have the client running, so
so I can type npm and it comes up with help or whatever.
Oh,
but I don't.
You know what?
Yeah.
I just realized I'm missing a step here. I'm missing the step where here it is. So this, if you click on this link, I didn't think this all the way through. If you click on this Node.js client link,
right,
that is, you actually need to clone this this client repository. God, I didn't even think about that. Yeah, so there's one more step in there. You've got to download this client directory, which you could download from GitHub or clone it. And then once you have it there, then you run this domain key, npm start in that directory. Totally forgot about that step. And then so that's the client side, that's the core. And then on the kernel side, you'll need to go through and maybe create another directory called kernel, and then copy and paste this code. Maybe create a file called like index.js or server.js, and put this in there. I should probably add that as a step.
Yeah,
too.
I think we. In conclusion, we're waiting. We're waiting for the tutorial. No,
yeah, and this
is good.
This is highly experimental, so I do break things, and it's use it to your own risk at the moment.
No, this is great for people who know what they're doing, but I feel the need for the tutorial to get people started, and I'm sure that someone will do this in the next, month, 2 months, and then we'll be good.
Yep.
Step-by-step tutorial. Chris, AWS, if you think about it, you're very familiar with it. I think most people who are listening are. But AWS is actually a pretty daunting thing. If there wasn't instructions somewhere, step-by-step, how do you set up your various Amazon accounts, it would be actually pretty hard for anybody who isn't right in there, technically. But because this stuff is all, and not necessarily by Amazon, by the way, but it's documented in a way that you go, oh, okay, this is what the key means, this is what I need to do, blah, blah, blah. And when you download stuff from AWS, other, independent things that have been done, and this is true of Rackspace and other places too, it's usually defined in a way that, basically an idiot can just do it. So that's what we need to get to.
That's how you get mass adoption, right? You've got to make this, where you can do hello world in 5 minutes.
Exactly.
And I think that's, when the platform's a little bit more stable, and I love some of Tim's ideas, I think that will help us get to computes in 5 minutes.
But I think this is a monumental thing, very, very interesting, and we all appreciate you giving us the scoop on it. And I know you have to go soon, so anything you want to say that we haven't said, or domains, or causes that you want to promote, go ahead.
No, so I am looking for experiments. So if you have ideas or things you want to run on the platform, I am looking for larger scale, something in the hundreds or more of cores. I saw someone ran something with 150 cores on it last weekend. That worked out well, but I'm looking for more test cases. So hit me up if you got ideas.
Okay, go to Computes.io and contact Chris, or contact him through us if you need to. Anything else, anybody, before we go? We got to let him go. All right, we're going to let him go. This has been VC 586 with Chris Matthieu talking about Computes.io, and we are going to take it out, and stay tuned for the mature audiences.
I want to make an announcement.
I already did when you weren't here, but
okay, cool. I'll shut up then.
You mean this?
Yeah, well, and the following thing. So later in the week, the Global Summit, we have a Cranky Geek talk that I'm doing, and Dan's doing Dan Jenkins is doing a how to get started with WebRTC talk on the Monday, and then on the Tuesday we're doing a workshop on whether IoT and WebRTC should be best friends or don't mix at all. So I've hopefully, touch wood and everything, I've lined up some nice speakers for that and some good toys to play with in the afternoon. So we'll see how that plays out. So that's on the 12th of April.
Okay, that's excellent, and next time send me a slide and we'll be able to actually promote it at the beginning and the end. Hey, we're going to go now live to Peter Dunkley's wedding, but before we do, we need to move to the mature audiences only version. Why is Tim visible there? That's me after the dentist. All right, here's James reflecting on what he's going to do. Good night, everybody. Thank you, Chris Matthieu. Always happy to have you.
Yep, a blast talking with the old gang again. Thank you so much for having me.
Always happy to have you, Chris. Take care. Here we go.
Yeah.